as the prompt for the, if you want to ask input data, you do a form string, a format string, and this is going into a widget, a doll doc widget. Anyway, I don't use a resource file. Normally you would do dialog boxes in a resource file. I don't do that. I like it all in one file. Well, anyway, so we're getting into the document. You have a lock that keeps different people from modifying the document. The screen updates, the window manager updates the different window. Each window has documents, and you want the window manager not to interfere with the editor when you're editing a document. So there's the window manager globals. These are compiler options. Now we're getting into the compiler internal stuff, the raw data types, and the intermediate code for the compiler. It's a stack machine intermediate code. Intermediate code, it's kind of complicated. What is this? CM code miscellaneous. Okay, that's getting into the jump. When you have a switch statement, you have jumps, and when you have string constants, those go into the that's all the junk that gets compiled and data placed after the function code. That includes string constants, jump tables. That's data that's part of the code, but it's in other compilers they have different segments for data, code, and stuff. I just put my data just after the code. And I compile function by function, just one function at a time, and then I put the data after it in the binary file, or if it goes into memory. These are this is for my assembler opcodes. Now these are some. Now we're getting into the definitions for registers. Now these right here tell. These are flags that tell what registers are used by the compiler, what's clobbered, what's preserved. Some of the registers are some of the registers are irregular. 12 and 13 are irregular. Anyway, that's because the SIB and modder. Anyway, so this is for the assembler, a bunch of stuff. This is the assembler addressing modes, flags, hash table. There's the opcodes go into a hash table. This is the binary file. The compiler makes a binary file. What's this? If it's making it ahead of time code, it uses that structure. Just-in-time code is actually easier to do than ahead of time code, than a binary file. If you think about it, isn't that interesting that just-in-time code is easier than ahead of time? So the Lex structure is basically the structure it carries around as it compiles. The code goes into so everywhere in the compiler it passes a Lex structure, and the Lex structure has stuff like well, it has everything goes in the Lex structure except the ahead of time structure. Okay, I put all my compiler global variables together, assembler, unassembled globals. PCI devices, that's not really used. ATA rep, well, ATA is the hard disk. The TAPI is CD-ROM. These are the command codes for the hard disk access when it's doing port I/O. File masks, boot record. Now we're getting into the Red C and the FAT32 structures, and the ISO 9660 structures. That's the file system for CD-ROMs. Now we're looking at the attributes, and when you make a directory, the Red Sea native structure. Now we're getting into file utilities. This is these are something you will use for instead of find first, find next like standard C. You use find files. Anyway, block devices. Now we're going to get into drives. Used to be called partitions. Drives. And this is the global variables for the disk code. The file access. What is this? Find. I don't remember what this is. Oh, C file. Okay, well, that's like when you call fopen. Fopen. I don't know why it's FF. Anyway, what do we have? The internal memory. This is for memory management. Heaps and block pools. Raster operations for the graphics. Here's the colors. The colors are defined. I went ahead and, if God said 16 colors, I made it for all time. So instead of doing this for a better namespace collision, I went ahead and I did it for, we know it's always going to be small scale because I set it a limit of 100,000 lines of code. So when you have bigger files, you want longer names, but mine is small, so I can use short names like that. Anyway, so keyboard global variables, mouse global variables for the mouse pointer and stuff. Input pointer is what I call. You might have a joystick, but we don't have joysticks anymore. You can make Control G, Control Shift G, Control Alt G, make a grid on the screen. The scroll bars controls like a slider. There's a slider control. The menu at the top of the screen, that's what we're looking at. See menu. Exceptions, that's an internal thing for exceptions. What's SVC? That's server. When you have inter-task communication and if you put text in another task standard in, or you have a server task that has a master, then you do inter-task communication jobs and stuff. Messages get passed between tasks. My messages, my messages are stored as bits, and there's only so many types that you use. Windows gets thousands of message codes. I only have about 15 different message codes. So this is for tasks. Each task has a structure. FS points to the current task record. GS points to the current CPU record. TSSs that's the Intel low-level structure for a task. Mine is ring 0 only, and I never use the hardware task support because I never change privilege levels or anything. So if you're using the debugger, there's a alias for FS is the task record. So this will access this will access the stored register. When it does a task context switch, it stores the registers in the current task record. This is the CPU. GS points to the current CPU. I made an area for the page tables. I identity map everything. So I have a fixed size for my page tables. They're identity mapped. I go ahead and map. Right here is the limit of how many pages I map. It's set to 128 gig of RAM maximum. If you want more, you can change that. Scan codes and scan code flags. The scan codes are similar to ASCII, except it's for a keyboard, and on a keyboard you have things which aren't ASCII. The cursor keys are not ASCII, but they have scan codes. I put the it used to be 2-byte scan codes. That's the most natural, but what I do is I put the prefix. There's an escape byte for bit 8 is a E0 prefix. If you know what scan codes are, you know what I'm talking about. What I do, instead of having an E0 2-byte code, I put E0 bit as bit 8. Normally bit 8 is for a new key. I shift it around a little bit. This is the device context for graphics. CDC device context. So it has a pen width, it has a brush. Basically, you can imagine that if you have two people writing to the screen, you want one to set the color to blue and another to set the color to red. Two different windows. Anyway, they need their own color for their device context. So, anyway, this is the compression routine archive. What do we have here? String utilities, string find, list, keyboard globals, sound. It'll record. It's only a frequency in it. If you're making a video, it will record what you set the frequency to. Debugger. What else we have? That's the end. Oh, good.